residents of Zaria are going to have this mean or average value. So this is one of the aspects of inferential statistics. So it's all about what? Trying to assist you to make what? Estimations, to make predictions, and to test hypotheses. These are the key things. It's all like the case of descriptive, where it is telling you which one is the highest, where is the median, what is the standard deviation of the values from the mean, what is the variance. That one is just describing, telling us more about what is happening in the data, but it's not telling us what, do this and do that. So inferential statistics is the one that will guide us to say that, okay, since I have gotten this mean, definitely there is going to what? We are going to have a positive outcome, or it's going to be a negative outcome. What is the importance of inferential statistics to biostatistics? One, it determines whether a new drug is effective, as you are coming to see in the case of t-test, as well as in the z-test, as chi-square, and some other tests. Number two, it will allow us to compare disease prevalence between populations. You can say COVID-19, as we have seen, is very, very stubborn to all people, unlike younger generations. How did they arrive at that? It's from this kind of statistical tool. So you need to understand that. Understanding inferential statistics will guide you to compare prevalences of diseases between population. It can also assist you to predict health outcomes, as we are coming to see in public health policies. What are the basic concepts of these inferential statistics? I hope you are taking note. Okay, I hope you are taking note. The basic concepts are one, population. We have already defined what is meant by population. That is complete group under study. Complete Zaria, you can say Kaduna, or you can say that is if you are taking Kaduna as a population, then Zaria can be a sample because Zaria is a subset of Kaduna. So whatever is the main group is what is meant by populations. We're not talking about the number of people that are there. No. Okay. The entire group on that study. Number two, sample, which we say is subset of the populations. We know what is meant by the parameter. Is the numerical summary of population. Example, the mean. Numerical summary of the populations. Then we have the statistic, you know, that is numerical summary of the sample. The only new one is sampling error, difference between a sample, the statistic, and the actual population parameter. That is sample error. If you are asked to calculate the sample error, you need to subtract the statistics mean from the population parameter, which is the mean of the populations. What are the types of inferential statistics? We have estimations. And under estimations, we have population estimations. That is a single best estimate of the population parameter. Then we have the interval estimations, which is the confidence interval. That is the range within which the parameter is likely to lie, and which we are going to discuss in detail today, inshallah. Confidence level, which we say is the range within which the parameter is likely to lie, that is likely to have, is a range. How we are getting it? It's like you have a child and he went out without you knowing. Then you now said it's likely that you are going to find him between so-so house and the so-so house. That is your confidence interval. So the mean is going to lie between 10 and 15, or is going to be between 100 and 120. That's the confidence interval. So these are the basic two types of inferential statistics. Point estimate, which is normally what we have been doing in our descriptive. So it's the single base estimate of the population parameter. That is the actual, if you may use the words. But the confidence interval is likelihood. It's likely that the mean is going to be between this and that. So now, what is this confidence level and confidence interval? There are two words, confidence level and confidence interval. Confidence level and confidence interval. So let's look at the first one. A confidence level represents the probability that the calculated confidence interval contains the true population parameter. Listen. A confidence level, that CL, represents the probability that the calculated confidence interval contains the true population's parameter. That what you have calculated as your confidence interval really is going to contain the true population parameter. That's your true parameter is lying in between the confidence level. Common confidence levels are 100%, 90%, 95%, and 100%. 99%. We can never have 100%. Okay? So the common confidence levels are 90, that you are 90% sure that the population parameter is lying in between the confidence interval you calculated. You are 95% sure that the confidence, the population parameter is lying within the confidence interval. So let's take for example, when we said I am a 95% confidence level, means that if we took 100% random samples, if we took 100%, 100 random samples, about 95 of the calculated confidence interval would contain the true parameter. That we're only going to have only 5 that are not going to fall within the confidence interval of the population parameter. Please get to understand. A 95% confidence level means that if you took 100 random sample of what populations about 95 of those that you took and calculated confidence interval with, they would contain the true parameter. It's like in your family, you will find that some children look exactly like their, let's say like their father. So what we are saying is, if somebody come and pick 4 out of 5 from that family, they are going to look exactly alike. If I say, okay, I'm 95%, 95% confidence level, it means 4 out of 5, they are going to look exactly like their father. It's like in your class, we're almost 100. So I've been taking statistics of attendance. I think yesterday we have very impressive often. We'll have almost 60, but rarely we see that we exceed 70. So from, let's say I'm using that because someday we are going to have 45, someday 50 out of 90. So I may use this data and say my confidence interval is what? For passing these exams in this class is 90. What I'm seeing, out of 90 students that anybody can come and pick at random, you find that they have the chances to get A in this course. What is the formula for this confidence interval? With mean none, that you know the mean, not that you don't know the mean, the mean of, if you must know the mean before you use this formula. So our confidence interval, don't forget please, we have confidence level which are 90, 95, and 99. Then we use the confidence levels to calculate the confidence interval. And for you to calculate the confidence interval, don't forget confidence interval is a range of values which contain the likelihood of having the population parameter, the true parameter. So you can see the confidence interval, CL, is equal to X bar plus or minus Z subscript alpha 2 over 2 times sigma root of n. What is X bar? Sample mean. You know, we said you are going to take sample from what? Populations. Sample from the populations. Then what is Z alpha? Z alpha is equals to what? The Z score for desired confidence level. Can I remind you that confidence level is 90, 95, 99. These are the most common confidence level. Alpha is the population standard deviations. We remember used different formula to calculate standard deviation for sample, and then for what? For what's it called? For populations. Small letter n stands for sample size. Please master these equations. The equation is saying CL is equals to X bar plus or minus Z alpha over 2 times sigma all over root n. Yes. Okay. How do I calculate or evaluate my z-scores for confidence levels? How do I go for that? The first thing to do, you select your what? CL. And that is what? You choose either 90. Sometimes in the questions, they will tell you what? They will tell you the confidence level that you are going to use. Sometimes you are the one to choose. So the first thing to do is you calculate your common, okay, you pick your common level. You can say 90. You can say 95. You can say 99 if the questions doesn't stated any. Then the next thing, you calculate your alpha. And your alpha is equals to 1 minus CL. That if I pick my CL as 90, my alpha will be what? Will be 0.01. Don't forget, it's 90 over 100. 90 over 100 is 0.9. 0.9. So you minus 0.9 from 1. See the example below. For a confidence level of 95%, my alpha is equals to 1 minus 0.95. So my alpha here is 0.05. Please, let's be guided. It's a very simple. This is a very, very simple, but you have to pay attention. I want to calculate my alpha. My alpha is the same thing as 1 minus CL. Mind you, CL is confidence level. And this constant, they are constant. They are either 90, 95, and 99, whichever one you choose. So after choosing, you go to calculate your alpha, you minus. Then the step number 3 is for you to divide the alpha you calculated by 2. Okay? You calculate it by 2. You divide it, sorry, by 2. Because the confidence interval is 2 tail. Yes, we have the what? We have the minimum, we have the maximum. It's a 2 tail. And that is the reason why we divide alpha by 2 to give the probability in each tail. It's a 2 tail. Okay? So that is why we are dividing by 2. What are we dividing by 2? The alpha we calculated in step number 2. And this, the alpha for 95% is 0.05. So you divide it by 2. Then you get 0.025. The next thing, you go to the table, the Z table, which you are going to start using by next week. So I'm going to send a copy so that everybody will have a copy. As the lecture is going on, you now be mastering the table, because that is going to be our lecture for Saturday, inshallah. Then how do you locate the Z-score and the Z table? You now use these 2 values that you calculated. That is to find the Z value where the cumulative property equals to 1 minus alpha over 2. That is for 95% CL, 1 minus 0.0 is equivalent to what? 0.975. Then you go to the table. When you go to the table, you now locate the z-value. But for our own case today, the z-value in the table is equivalent to 1.96. Yes, somebody will say, look into that. What is the interpretation? You interpret that the z-value is 1.96. This means that 95% of the data lies within 1.96 standard deviations from the mean. 95% of the data lies within 1.6 standard deviations from the mean. So it means almost all, you see the value, if the standard deviations of the sample is given, you compare. So the interpretation is saying 95% of the data lies deviation from the mean. It's either going to be 1.955 or 1.96 to 1.965, somewhere around there. So they are lying within that particular value, 95% of the data. Now, for the sake of this topic, I summarized the confidence level with their what? With their alpha over 2 and their corresponding z-score. All you need to do will master the confidence level and then the corresponding z-score. So for 90, you don't need to go to the table. Once you pick the confidence level of 90, the z-score is 1.645. It's constant. If you took 95% confidence level, the z-score is 1.960. If you took 99, the z-value is 2.576. So these are constant. You just master them. Let's look at some examples here. Determine the z-score of 99 confidence level. This is a very simple case. The first thing to do is the what? You have your CL, so your CL is 0.99. You subtract 0.99 from what? From 1. How are you getting it? Look at what happened. Your CL is 0.99. So when you subtract 0.99 from 1, you get 0.01. Then you calculate, you divide it by 2. Then you subtract, and then you get your what? Your alpha over 2. Look at what is happening. Don't be confused. The first thing, we have chosen CL, our CL. We are given confidence level of what? 99. And the next thing, according to our steps that we explained earlier on, let me take you back where you can see the steps. You see? So to get our alpha, we subtract. You can see here. This is what we need to do. You see? To get your alpha, you subtract 1. So you see CL from your 1. That is to get your alpha. Then you divide your alpha into 2 to get the 2-tail probability. And this is what? Then you take this 0.25 and go and find your what? To go and find your z-score. So the same thing here. Look at it. Look at it. This is our CL, you can see. So the next thing, we'll get our alpha. So how do you get our alpha? We'll subtract 1. Sorry, 0.99 from 1. That is how we got our alpha. How are you getting it? Or let me make it this way so that you can understand. Look at what happens. From here, then we'll go to this place. From here, we'll go to this place. Then from here, we'll move to the steps. These are the steps. First, look at what happens. How are we getting it? So after I've gotten my after I've gotten my alpha, I divided the alpha into 2. So I got 0.05. So the cumulative probability 1 minus 0.05, which is equal to 0.995. So taking these values, okay, let's go to our table for 99. For 99, look at it. For 99, you see 99%. So look at the z value. So the z score is here. And this is what we got here. This one is from the table, okay? It's from the table. It's from the table. I'm just trying to show you how to calculate if the table is not available. So if those particular constant I gave you, you couldn't be able to remember the values. Let me repeat myself. You have been given the confidence level 0.99. I want to find alpha. So I subtract CL from 1. I got alpha 0.01. To get my 2 tail, I divided the alpha into 2, which is 0.005. Then, for me to get the cumulative probability, I minus 1, 0.05 from 1, which is 0.99. Then I will take this 0.99 to go to the table. I think, okay, to save time, for you to understand, let me see if I can be able to get this table. Please, where is it? Where is it? Table. Yeah, I have one here. Let us wait for this table. Look at the table. You can see the table. So I will send the table to you. So you can see, this is the table. Cumulative standardized normal distributions. Okay. Standard what? So you can see this table here. Look at it. You can see the values. This is the z-score, and this is the a-value. And this is what we have done. What we did for the second question is what? Look at it here. You see, we calculated cumulative probability of what? 0.995. 0. Look at what we calculated here. From finding alpha, divide alpha by 2, and then we subtract to get cumulative, then we got 0.995. Then you go to the table here. You now look at it. Okay. Look at where is 0.995? Look at it here. What is the z value here? This is the z value. You can see 2.576. This is how to go about it. Or if you want to go to the table, look at the table entirely. You calculated 9.995. 9.995. That's what you calculated. Okay, so you can see under what? So you can, so you come down, is your, you go down, 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 you go down. Okay, so your value is within what? Is within this value, this 2. That is between 2.5 and 2.6. Well, I don't want to take you, we'll do all these things, inshallah, in this class, so that we'll have, because next class, we're going to study this table from the beginning to the end. So everybody should come with this calculator, okay? So you can see the table, we have the table here. We have the T distribution table, you have it here. So you can see the F distribution at 5 significant level. You can see. So we are going to study this table. Okay, we'll study the table, then to know how, but for the meantime, our problem have been solved here. Okay, for 0.995, the value that we calculated here, look at it here, this is the value. Now, from the Z table, the value is what? 2.576. Okay, this is the interpretation, that the margin of error extends plus or minus standard deviation from the mean. Okay, so when you now take 99%, there is a high chances of plus or minus that the values deviated from the actual mean of the populations. So this is that. Here we have given a sample of 150 diabetic patients has a mean fasting blood sugar of 130 milligram per DL. The population standard deviation is 15. So you can see here, we have been given the population standard deviation, which is sigma. Then construct a 95% confidence interval. Mind you, we don't construct confidence level. We only construct confidence interval. What is my mean? 130. What is my sigma? 15. What is n? 150. What is my alpha over 2? The z value at alpha over 2 is Because yes, somebody will not tell me. For 95%, the alpha over 2 is 0.025. And we know it's constant, the z value. Hey, let me take you back so that you know. Look at it. For 95%, look at it. The z score is here. Alpha over 2 is 0.25. So once you have that, you master, all you need to master this column and master the last column. 90 goes with what? 1.645. 95 goes with what? 1.96. 99 goes with what? 2.576. That's all. You have master. You can see I calculated. So this is what I have. So going back to my equations, I inserted the values. 130, which is x bar. Can you recall? This is the equation. Look at it. Look at the equation. Go. Look at the equation. It's x bar plus or minus z alpha over 2 times sigma all over root of n. So you can have it. See. So you can see. So the first thing to do is you add 1.96 to 130. When you add, you multiply by 15, and then you divide it by square root of 50, 150. It will give you this value. Look at it here, which is the lower, the first term, lower value. You know, confidence interval we say is a range within which the true value is lying. Then you subtract. Okay, now you are sorry, the first one you subtract 130 minus 1.96. It will give you this value. Then the second value is 130 plus 1.96 multiply by 15 all over root of 2. You get this value. So by implication, by interpretation, it's telling you the true value is lying between 127.6 and 132.4 at impedance. That the true value is in between 127.6. So the same thing with example number 3. Okay, the same thing. Look at it. A study of 100 nursing students found a mean test score of 75. Okay, with a population standard deviation of 10. Find the 99% confidence interval for the mean. So you do the same thing. So at the end of your calculations, you arrive at what? 72.42 and then 77.58. The same thing with example number 3. So they are all the same thing. Okay. So this is how to calculate what is interval, confidence interval, and what is confidence level. Confidence level, common confidence level, 90%, which is 0.9, 95%, which is 0.95, and then 99, which is 0.99. You calculate your alpha, you subtract CL from 1, you get your alpha. Then you get alpha over 2. Then you get cumulative, okay, probability by subtracting alpha over 2 from 1. Then that will give you the E normal distributions. So you use it. But if you are constructing the interval level, then there's the equations. Okay, we say x mean plus or minus z alpha over 2 times deviations all over the root of 64. One area where maybe you can look at before you now be holding your equations, this is what we are going to discuss next week. That is okay. So we're going into hypothesis tests. So I don't want to take you to this. What I want you is please, you can scan, you can write, you can scan this exercise, and also you do it, and then you also submit to our assignment platform. Okay, or I will take it and then you do it and submit on Wednesday. So now, time for questions if you have, only on today's class. Don't bring any issue that has to do with yesterday or day before yesterday, please. If you have any question as such, go and place it in our WhatsApp platform. But this time around, strictly on what we have discussed today. So the door is open for you to ask questions on what we have discussed. Thank you very much. Any question? Any questions?
No, sir.
Everything well understood?
Hello, excuse me, sir.
You're welcome.
Okay. You said we can only construct
Confidence
is it the
confidence
confidence
interval, that
okay.
is. Yes.
Hello, sir. Good evening, sir.
You're welcome.
Well done, sir.
Thank
Sir,
you.
about the assignment that given to us that you are submitted tomorrow, sir.
Please, I said, ask only question that has to do with this lecture. Any question, ask only question that has to do with today's lecture.
The lecture, okay, sir. Ó ti tún lọ wò láyé mi o.
Good evening, sir. Sir, I just want to, I don't know if you can hear me, sir.
Yes, I'm hearing.
All right. So I just want to clarify this confidence level. When you said that, this confidence level, when you said it's within 90, 95, and 99. So when we wanted to calculate it, a confidence level equals alpha.
Confidence level is not alpha.
Star on
Yes. Alpha equals 9 minus 0.95. So I want to ask that why did you use it as decimal and not just as the 90, either 90, 95, or 99?
How can you, okay, how can you subtract 90 from? What is 90% means?
Okay, it's in percentage.
What is 90% means?
That's 90 over 100.
That is it. So you can't subtract 90 from 1. You're going to have minus 89. How can you say? And even 90% is not the same thing as 90. It's 0.9. You multiply by 100. So you have to convert it to its actual expression. That is 0.9 or 0.95 or 0.99. Then you do the subtraction. Yes, any question? I can see only 22 people wrote their attendance, 22 out of 57. Please don't come tomorrow and be complaining. Any other question, please? Any other questions? We are answering questions, we're entertaining questions as regards to what we have just discussed today, not yesterday. No questions? So, in the absence of questions, I will say thank you and wish you all the best. We shall meet on Friday for the test. This time around, we are going to have 3 topics.